Welcome to Unit 1, Lesson 1, Number Properties. Today we're going to talk about how to use the commutative property of addition, the associative property of addition, the identity property of addition, the commutative property of multiplication, the associative property of multiplication, the identity property of multiplication, the zero product property, and the distributive property. There's a lot of properties here, but you'll find that a lot of the properties are similar, if not the same. So when we talk about the commutative property, you'll notice that we have a commutative property for both addition and multiplication. And we also have an associative property for both addition and multiplication. These properties are very similar, and they work very much the same. It's just important to note how they work and what they work with. And then you'll notice that we'll talk about the identity properties. The identity properties, however, are quite different when it comes to addition and multiplication. They have the same idea behind them, however, it's not the same pieces that help them work. So let's go ahead and start. We're going to do vocabulary at the end of this lesson. So first we're going to start with associative property of addition. So if I were to take this problem and work it out, I know that I would have to do parentheses first and then add the 5. So I know that I would get 12 plus 5. And then I know that I would get 17. So now I want to know what happens if I move those parentheses and I do the 5 plus the 10 first. Well, I get 15 plus 2, and I still end up with an answer of 17. Notice that the associative property has moved the grouping. So when we talk about groupings, we're talking about these parentheses that you see right here. So right here, these are called parentheses, and we'll typically refer to those as groupings. So if you hear somebody say 5 plus the quantity 10 plus 2, that's telling you that 10 plus 2 is inside of parentheses. It's part of a grouping. So the associative property allows us to move these parentheses. So here it was around the 10 and the 2, and I moved them to be around the 5 and the 10. There is an important piece here though. Notice that both of these are addition. If one is addition and one is subtraction, this will not work. When it comes to adding, we can move our numbers and parentheses around as we please, because when you move numbers around and add them together, you get the same thing. So with the associative property, we can move that grouping and it will not change the answer. Okay, and in terms of the associative property of addition, that tells us that if we're adding numbers together and it's all addition, I can move that grouping. Right, so here I have 7 plus the quantity 3 plus 12. Well, looking at it, these are fairly simple numbers to add together. So why would I want to move these groupings? Well, if I move the groupings, because I want to make it easier to do in my head. Now there's the key word. Easy enough to do in my head. We want to get faster at our math facts and adding and subtracting in our heads. And I know that when I'm adding with the numbers 10 or 20 or 30, numbers that are multiples of 10 are significantly easier to add by because of the fact that they have zeros here. So instead of adding 3 plus 12 first and getting 15 and then having to add 7, I can move my grouping and add 7 plus 3 first. Okay, why did this make it easier? Because now I did 7 plus 3 first, and I got 10. And then when I add here, it's really easy to say, okay, well 10 and 10 is 20, plus that extra 2 is 22. It's a bit easier than setting up 5 and 7 is 12, carrying the 1. We don't have to do that because we know how to easily add with multiples of 10. All right, so the associative property of multiplication. Notice it's the same words, so we have the associative property, but now we're dealing with multiplication. Again, if you look at how this works out, we have 10 times 2 is 20. And then we're going to multiply that by 5, and we're going to get 100. Well, what if I change that grouping and do the 5 times 10 first and get 50, and then do 50 times 2, which is 100? I get the same answer. And again, it makes it a little bit easier to do. Here we end up with multiples of 20 anyways, but it's easier for me to do 50 times 2. That's a number that or a multiplication problem that we typically know quickly off the top of our heads, whereas 5 times 20 might take us a little longer. All right, so if we move along here, it's the same idea. If I look at this problem, I have 5 times the quantity 2 times 12. So if you'd like, I'd like you to take a second and pause and see where you would shift these parentheses to make it easier to do in your head. All right, so I would move these parentheses over and do the 5 times 2 first. Now I want you to think about, why would we do 5 times 2 first? What does that get for us? Well, 5 times 2 gets us 10. So by doing that first, I'm multiplying by a multiple of 10, which is a lot easier to do. And if you don't know so already, the trick when you're multiplying by a multiple of 10, ignore the 0. So just ignore that for a second and do 1 times 12. Well, I know that 1 times 12 is 12. Now I can take this 1, 0 and add it to the end of my answer, and my answer is 120. Whereas if I would have done this the other way, I would have had to do 2 times 12, which would give me 24. And then I would have had to multiply that by 5. Now we can do that, and I know it's simple enough to set up the multiplication. However, 10 times 12 is a lot easier to do in our heads than 24 times 12. Right, so when we're going through these notes, my suggestion would be, when I'm going over problems like this, like the second part, I would definitely be writing that down. This first part that we went over, so these pages right here, you don't necessarily have to write down. We'll go over the definitions of these at the end. All right, commutative property. Some of you might recognize the word in here of commute, and we know that commute means to move. I'm moving from one place to the other. So if I look at 5 plus 6, I know 5 plus 6 gives me 11. And again, this is of addition. Okay, so if I do 5 plus 6, what do I get if I do 6 plus 5? Well, I get 11. So now what I want to look at is, what if I do 6 minus 5? Again, keyword here is addition. 6 minus 5 is 1. Well, what if I flip it and do 5 minus 6? Is that 1? Actually, it's not. So if I do 5 minus 6, 5 minus 6 actually gets me to negative 1. So here, when I flip my numbers around when doing subtraction, I don't get the same answer. So the commutative property does not work for subtraction. So no subtraction. This is really important. So the commutative property is what allows us to move our numbers around when we're adding. And it's not just two numbers. It can be 5 or 6 or 7, however many numbers. As long as we're adding them all together, we can move all those numbers around. Again, when we're moving numbers around, we want to make it easier to do in our head. So we're looking for numbers that are easier to get to 10. So when you're thinking about tens, I know that 1 and 9 get me to 10, 2 and 8, 3 and 7, 4 and 6, 5 and 5, and then again I could say 6 and 4, but those are all just repeating. So I look at this second number, so I have 2. Well, are there any other numbers that are in the ones place that easily add to 10 with 2? I know I'm looking for an 8, and I have one right here. So what I want to do is I actually want to put those two numbers together to check to see if I can do that, I have to look, am I adding? And I am. All of this is addition. So I can actually just take this 18 and switch places with the 4. Now here I've also put the 4, which is in the ones place, next to a number that has a 6 in the ones place, and 4 and 6 actually easily get me to 10. So this makes it easier to do in my head because now 2 plus 8 is 10, and then I have 10, and then another 10, which is 20, and another 10, which is 30. So now I have 30 plus, well, I know 4 and 6 is 10, plus 4 more 10s is 50. And now this is easy to do because I just do 3 plus 5, which is 8, and 0 is 80. Again, this makes it significantly easier to do because of the fact that I got 2 multiples of 10. Right? And again, what allows us to do this? That commutative property that lets us move numbers around. So now, let's look at it with multiplication. So 10 times 2, I know that gives me 20. 2 times 10 gives me 20. But 10 divided by 2, that gives me 5. If I take 10 and I put it into groups of 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know I get 2, 3, 4. There we go. So 2, 4, 6, 8, 10. That gives me 5 groups. Well, now if I take 2, and this is where it gets a little bit harder to understand. So here's 2. 1, 2. Now I want to divide that into 10 pieces. Well, if I divide that into 10 pieces, I have to break each bar into 5 pieces. Since this whole thing is 1, this is 1/5, 1/5, 1/5, 1/5, 1/5. Okay, so 2 divided by 10 is actually giving me 1/5 because I'm taking these 2 big pieces and I'm cutting them into 10 smaller pieces. And since the pieces are getting smaller, their value is getting smaller. So instead of this whole thing being worth 2, each of them is now worth 1/5. So notice it's addition and multiplication that have all these properties, because addition and multiplication are the only operations that allow us to move numbers around and still get the same answer. So again, just like no subtraction, no division. Does not work for commutative or associative. Okay, and then just like the other ones, we want to look for numbers that are going to get us to a multiple of 10 and easily. So I know I could do 12 times 4, and in my head I know that that's 48. And then I might know what 12 times 5 is off the top of my head. Okay, and that would be 60, but sometimes it's a little bit harder for us to do. So let's make it easier. Since I know that 5 times 4 is 20, I can do that first. So now I get 20 times 12. Again, I ignore the 0 and I do 12 times 2, which I know is 24. And I add that 0 to the end and I get 240. That made it so much simpler to do in my head. Okay, so look for those numbers that are going to get you to 10, 20, 30, 40, and so on and so forth. All right, and then again, what allows us to do that is the commutative property. All right, getting through these, we're looking at this next piece, and I want to know what number is the only number that you can add to any other number and get that exact same number for an answer. So if I said 4 plus something gives me 4, what would that something be? If you said 0, you would be correct. So 0 plays a key role when it comes to both addition and multiplication. It's very important to keep the two separate and understand that they do two completely different things when it comes to multiplication and addition. So right now with addition, 0 is involved in the identity property. When we talk about the identity property, I want you to think of the word identity. So the identity means like who you are, who something is, or what something is. So the identity property allows a number to keep its identity. It allows that number to stay the same or continue to be itself. So no matter what I add 0 to, that number gets to stay the same. So if I take 5 plus 0, I know that I'm going to get 5. I can take 2 times 0, and I know that I'm going to get 2. No matter what number I add to 0, it's going to stay the same. So I have 100 plus 0 is 100. And this even extends to fractions. So if I have 3/4 plus 0, that's still going to be 3/4. And even decimals, if I have 1 and 800ths plus 0, because it's adding and it's adding a 0, it's going to stay the same. So that identity property of addition is when you add 0 to any number, that number stays the same. Right? And then looking forward, what number is the only number that you can multiply to any other number and get that exact same number for an answer? So if I said 5 times this number is 5, what is that missing number? And be careful, it's not 0. 0 only works when we're talking about addition. We're talking about multiplication, so this is completely different. So now that number is no longer 0, it is 1. So now I know that anytime I see a number times 1, my answer is going to be exactly that number. So 5 times 1 is 5. 2 times 1 is 2. Again, 100 times 1 is 100. Again, this works for fractions. So 3/4 times 1 is going to give you 3/4. And 1 and 800ths times 1 is going to give you 1 and 800ths. Okay, so the identity property of multiplication uses 1. So any number times 1 equals itself. So you might want to write down a couple of these examples in your notebook. And don't worry, you can always go back and rewind and pause and get those put in there. All right, so looking at these problems, let's do a quick review. Since it's all addition, I want you to take a second and pause, and I want you to rearrange it to make it easier to do in your head. And when you come back, we'll check your answer. All right, so to make this easier to do in my head, I would take and put this 7 and this 3 together because I know 7 and 3 gives me 10. And then I would put this 5 and this 5 together because I know that 15 and 5 also, that 5 and 5 also gives me 10. So 17 plus 3, 7 and 3 is 10, plus 1 more 10 is 20, plus 5 and 5 is 10, plus 1 more 10, because that's in the tens place, is 20, so I get 40. All right, and then why don't you go ahead and pause and try the bottom one and see what you come up with. Again, I would put together the 4 times 5 times 9 because I would get 20 times 9. I ignore that 0 and I have 2 times 9, which is 18. And then I add that 0 to the end and I get 180. Right, so a lot of our properties have dealt with multiplication and division, multiplication and addition. And those again are the only properties that you can move around freely without changing the answer. All right, one of the last ones, we're almost done. So we have a number that we multiply to any other number and we get 0. So no matter what I multiply this number by, I get 0. This is where that pesky 0 gets to be a little bit complicated. With addition, anything plus 0 is itself. But with multiplication, anything times 0 is 0. So what this means is if I take 5 times 0, I get 0. If I take 3/4 times 0, I get 0. If I take 1 3400 times 0, I get 0. So the zero product property, notice it has product in there. Product means the answer to a multiplication problem. So what that is telling us is that 0 is the product whenever you multiply any number by 0. So again, this is different from the identity property of addition because when you add 0, the number stays the same. When you multiply 0, your answer becomes 0. So even if you have 15, 20, 30 numbers and in there somewhere you have times 0, your answer has to be 0. Okay, so without writing it out, let's take a look at this problem and make it easier to do in our heads. I could sit and do 12 times 45 and then multiply it by 0, then multiply it by 2, then multiply it by 1. But here's the thing. Since all of these are multiplication, no matter what I do, my answer is going to be 0. Let's start with 45 times 0. Well, that's going to be 0. So then I could do 12 times 0 would be 0. Notice I'm just bringing everything else down. 0 times 2 is 0. Times 1 is 0. So even though I only had that one multiply by 0 in there, it still gave me an answer of 0. So whenever you're looking at problems that have several or all multiplication, check to see if you have a 0 in there because you know right away your answer has to be 0. All right, last but not least, we have the distributive property. So when we do the distributive property, typically what we do is we say that we do 5 times, well, here's 2 plus 3 is 5, and then we get 25. Now, this is easy to do in our heads, but when we're working with larger numbers, using the distributive property can be very helpful. So what if I were to take the 5 and share it with the 2 and share it with the 3? Okay, because I'm multiplying 5 by this quantity. If I take 5 times 2, I get 10, plus 5 times 3, which is 15. Add them together and you get 25. The distributive property allows us to, if you're taking a number and multiplying it by a quantity, you can distribute that number and make the problem easier to do. So if we take a look here, actually I'm going to go back before we move on. Let's say that I'm trying to do 2 times 45 in my head. Yeah, I know that this is 90, but just to give you a quick example, I could break this into 2 times 40 plus 5. Because if I add 40 plus 5 first, it gives me 45, so I'm kind of breaking it down and then building it back up. The distributive property allows me to do 2 times 40 plus 2 times 5. Well, I easily know that 2 times 40 is 80 and 2 times 5 is 10, and I can quickly add 80 and 10 in my head and find out that it's 90. So we want to work on using the distributive property to help us split apart numbers and make it easier to do multi-digit multiplication in our head. Don't worry, as time goes on and you get more practice with this, it'll become easier. All right, so we have a couple of questions that I'd like you to answer. You can write these down in your notebook and answer them, and then what I'd like you to do is to go on to Associative, and you need to enter the code, and once you get into that, you will answer your questions. I will give you the code in your emails, or it'll be on the Google Drive, or it'll be listed in class. Sometimes it may also be at the end of this video, so you have several places that you can look for that code. If you have any questions, or if there was any part of this that was confusing, please make sure to write it down in your notes and ask the question in class tomorrow, or make sure to shoot me an email with that question so that way we can address it right away at the beginning of class.